Imagine this. It's late at night. An engineer named Priya is sitting at her desk. Her table is a mess of papers, rulers, and half-empty coffee cups. She is designing a single beam for a new building. This isn't just any piece of wood or steel. This beam has to be perfect. It has to hold up a roof, withstand wind, and keep everyone inside safe. Priya has been working on this one calculation for hours. Every number has to be checked and rechecked. One tiny mistake could mean disaster. This was the reality for engineers not too long ago. It was a world of manual calculations, endless formulas, and a lot of stress. The process was incredibly slow and filled with anxiety. Each beam in a structure required its own set of complex mathematical equations. Engineers had to consider the material of the beam, like steel, concrete. They had to think about the load it would carry, from the weight of the floor above it to the weight of snow in the winter. They would spend days, sometimes even weeks, just to ensure that their designs were structurally sound. It was a mentally draining task that demanded absolute precision, leaving little room for creative problem-solving. Think about the tools they used back then. They had slide rules, which were like ancient calculators. The dream was always to find a faster, more reliable way to do this critical work. So, what exactly is a beam calculator? Let's break it down in a simple way. Think of it as a special calculator designed just for engineers and builders. A regular calculator can add and subtract numbers. A beam calculator, however, understands the physics of structures. You tell it the length of a beam. You tell it the material it's made from. You tell it the weight it needs to support. Then, like magic, it does all the complicated math for you. It tells you if the beam is strong enough or if it will bend too much. It's a fundamental tool that helps ensure our buildings, bridges, and homes don't fall down. This tool is incredibly important in construction. Before the first brick is laid, an engineer has to be certain every structural element is safe. It takes the guesswork out of design. Instead of spending hours with pencil and paper, an engineer can get an answer in seconds. This allows them to test many different ideas quickly. What if we use a different type of steel? What if the beam is thicker? The calculator can answer these what-if questions almost instantly, making the design process much more dynamic and efficient. The introduction of these digital calculators was a game changer. It was like going from sending letters by pigeon to sending an email. The speed was revolutionary. Suddenly, projects that would have taken weeks to plan could be mapped out in days. This didn't just save time, it saved money. Fewer hours on manual calculations meant lower costs and more confidence in designs. So, how does artificial intelligence make these beam calculators even better? It's like giving the calculator a brain. A traditional beam calculator is like a student who has memorized the textbook. It knows all the formulas and can solve problems if you give it exact numbers. But an AI-powered beam calculator is like an experienced mentor. It has seen thousands of different real-world projects. It learns from every single calculation it performs. This learning makes it incredibly powerful for engineers. The AI works in the background, analyzing huge amounts of data from successful building designs, material science research, and even failed structures. The AI looks for patterns and connections that a human might miss. It constantly updates its knowledge base, getting smarter with every use. For example, it might notice that a certain beam design works best in high winds, or that a new lighter material can be just as strong. It's not just following instructions, it's providing insights. This separates AI calculators from older software. When an engineer inputs a design problem, the AI doesn't just solve the equation, it compares the problem to similar situations it has seen before. It can then suggest optimizations. For instance, it might say, your design is safe, but you could use 15% less steel if you slightly change the shape of the beam, saving you money without compromising safety.